Imagine you have a long row of flower plots, some of which are already planted and some of which are empty. Your task is to plant more flowers, but with a catch. No two flowers can be planted directly next to each other. To depict our problem a little more scientifically, we're going to use an array to represent our flower beds. We're going to use zeros to represent empty flower beds and ones to represent filled flower beds. And now we need to figure out if we can plant a certain number of new flowers without violating the adjacency rule. Before we can do this though, we need to understand the problem. Let's begin with understanding the inputs. Our inputs consist of an array for the flower bed and an integer n representing the number of flowers we wish to plant. The challenge is to determine if these flowers can be planted under the given conditions of the array. Now that we understand the problem a little better, let's take a look at the algorithm that we will use to solve it. We will traverse the flower bed array. For each empty plot, we check its neighboring plots. If both neighbors are empty, we can plant a flower there. Or, if the plot is at the start or at the end of the array, if the boundary and one neighbor are empty, then we can also plant a flower there. This will ensure that no two flowers will be adjacent. Now, let's implement this algorithm using Python 3. I'll talk you through it step by step. First, we begin by defining the function. This function is going to take two parameters, flower bed and n. Flower bed is a list of integers that represent the flower bed, where 0 indicates an empty plot and 1 indicates a filled plot. And n is the number of flowers that we want to plant. Then, we're going to make a variable called count. Count is going to be initialized to 0. This variable is going to keep track of the number of flowers that have been successfully planted. Then we're going to create a variable length, and length is assigned the length of the flower bed array. This is going to help us with our loop control and checking for our boundary conditions. Now we can start traversing our array using a for loop. So we're going to start a loop that iterates through each plot of the flower bed using its index I. As we're traversing our array, we were going to check that the current plot represented by I is empty, as represented by the 0. If it is not empty, the loop simply continues to the next iteration. We want to check if the current plot is the first plot or if the previous plot is empty. We're going to check this condition and assign it to the variable prev. We also want to check if the current plot is the last plot or if the next plot is empty. We're going to assign this to the variable next. These checks help us to ensure that planting a flower won't violate the no adjacent flowers rule. If the conditions that we set for prev and next are satisfied, a flower is planted in the current plot by setting flower bed at index I to 1. Then we're going to increment the count by 1 to reflect that one more flower has been successfully planted. This next conditional statement is written to check if the number of planted flowers, our count, has reached the required number, n. If it has, we're going to return true immediately, and we're not going to continue transversing through the rest of the array. This indicates that it is in fact possible to plant n flowers without violating the adjacency rule. After the loop has been completed, we're going to check if the total number of planted flowers is at least n. We return true if it is, otherwise we return false. Thanks for watching. Leave your questions in the comments. Bye.